Java is an object-oriented language. Everything is based on class. Um, to create a sample program to print welcome to Java, we have to start with class keyword only. Everything is based on class. We have to start with class keyword only. Starting with class keyword, we should give any name for the class. The class keyword, the sample is the name of the class. The name of the class is a name we can give the purpose of the program for what we create. The purpose of the program for what we create. Here we give sample class keyword name of the class sample. We can give any class name. Here we give sample starting with open brace. In C and C++, we have root of the program void main. Here also void main. We start with public static void main along with string arguers. We'll learn about the string arguers in later chapter. We should use the string arguer statement. To print a line, we use system.out.println statement. System.out.println statement. In C, we use printf statement. In C, we use printf statement. In C++, we use cout statement. Likewise, in this, we use system.out.println statement. System is also a class. System is also a class. It's a root class. Out is also an output class. We learn about input output class. Out is also a class. System is also a class. Out is also a class. In that we have a println functions. In that we have println functions. Here we pass what we want to print. Welcome to Java. Welcome to Java. Here we use system.out.println statement. Welcome. Here we give welcome to Java. Thank you. To compile the Java program, we use the statement javac program name.java. Javac is a Java compiler, and to execute or run, we use the statement java program name. Java program name. To compile, we use javac program name.java. To execute, we use Java program name statement. And later, I will show how to compile and run the program in real-time video. The Java can contain any number of classes. We have to find which class contains the void main statement. The Java can contain any number of classes. We have to find which class contains the void main functions. In this, we have only one class, the void main functions. The class name is sample. This class contains the void main functions. The name of the class is sample. So we save this Java source file as sample.java. Sample.java. This is printed wrongly. We save this file as javac. Save this file as java sample.java. We save this file as sample.java. Now we have to compile this Java program as javac sample.java. Javac sample.java. To run this program, we use the statement java sample. We just learned with a small example, class ESP1. It just print the welcome message, welcome to Java. Open command prompt window. The command prompt window is open. Now move to the desired drive where the program is saved. My program is saved in F colon. Move to the desired folder. My program saved in a BCL app folder. So just move CD BCL app. CD means change directory. Then we have to set the path of the Java. My Java was installing C program file jdk/me. This is the location of the Java where we have to install. My Java is installing C colon program file Java/jdk versions/bin. You have to find in your system where this um, bin folder is located. That path you should be set path equal to the path of your system locations. My system location C colon program file Java JDK versions 1.6/bin. Then to compile the program, just type Java C ESP1 dot Java. Java C ESP1 dot Java. Java C Java compile. To compile the Java program, just type Java C ESP1 dot Java. If you have any error, it will show error. Now this program no error, so it does not show any error. If it has any error, it will show. To run the Java program, just type Java ESP1. Now the welcome message is printed. Welcome to Java. To compile the program, Java C ESP1.java. To run the program, just Java ESP1. Before, you have to set the path. Set path equal to. Before studying about object, we should know about class members. What are the class members? The class members are the class members. Class contains only two members, data and methods. These are the members of classes. We normally say the class members. The class members contains data and class members contains methods. For example, in class example 1, we have class data and class method. In class data, we have two variables, A and B. In class method, we have only one method, void add method. We are in we print the addition of A and B. Now, what is objects in classes? What is object in classes? Objects are used to create to access the class members. Objects are used to create to access the class member. If you want to access the data and if you want to access the method, we must to create the class object. If you want to access, if you want to use the class data or want to use the class method, we should create object first. Like now, we learn about how to create the class object. For example, in class example 1, we can create object as first we write the class name object 1. First we write the class name object 1. Then we write the name of the object. We write the name of the object plus the class name. First the class name, then the name of the object, then the new operator, and then the class name, and then the class name as along with the parentheses. We can pause any values in the parentheses. Later we can see why should we use this syntax as methods. Okay, first the class name, class name, next to object name. The object name should be meaningful. Yeah, for learning plus we write as object OPJ. We can use any name. We can use any name. For class name, we should write the name of the class. Java is a case-sensitive language. Java is case-sensitive language. For example, it differentiates capital E and small e. Differentiate between capital E and small e. In the class, so we have to write a third class name. For example, one exp1. If you write e small e, we show error. So you should write the exact class name esp1, and object name, new operator, and then the class name. This is one of the format. This is one of the format. Then another format, without using the class name, we initiate the class name object. We initiate the class object. We initiate the object, and then later we allocate the memory, and then later we allocate the memory. Object equal to new class name. Object equal to new class name. You can easily create the object class name, object name, new operator, and class name along with the functions parentheses. We can pass any parameters. Later we can see the succeeding chapter. The new operator used to allocate the memory, used to create so as to we can allocate the memory to satisfy the storage requirement of class. To satisfy the storage requirement of class. Okay, the new operator used to allocate memory so that we can satisfy the memory requirements of classes. For example, in this class ESP1, in this class P1, the class keyword, the name of the class ESP1, we have one data members A and B. We create two integer variable A and B and one method add. In that method we add both the variable A plus B. In that method we add the both number A and B. The system dot out dot println. Uh, the basis one we already learned about the system dot out dot println. Uh, this class ESP1, the two variable integer A and B, void functions, void add. In that add function, we add both variable A plus B. Now we create the object ESP1, object name 1, new operator, the class name, new operator, the class name. Uh, Java is a case sensitive language. We have to write the assert class name, assert class name. If it is capital letter E, we should write the capital E. If it's small letter S, we should write the small letter S. If anything differentiate, it show the error. Okay. Okay. So object 1 dot A equal to 10. We can directly initiate the values. Object 1 dot B equal to 11. We give values to the both variable A and B. We already seen the object of creator to access the data members. For this data member A and B, for A we initiate value is 10. For B we initiate value with 11. Now we access the method object 1 dot add, object 1 dot add, object 1 dot add. We will print uh, 10 plus 11 21. It will print 10 plus 11 21. The object now I think we know how to create objects. The constructor is just like method, but no return type. The class name and the method name are identical. The class name and the method name are identical. The constructor is just like a method, but it has no return type, just like void, int, double float, etc. But
how can we can find whether it is method or constructor? The constructor name of the class name and the constructor name are identical. The name of the class name and the method name are identical. That is, they are same. They are same. The purpose to use the constructor is used to initialize the class variable. We normally create the constructor is used to initialize the class variable. Is used to initialize the class variable. Okay, now we see with a small example class add. Class add. The class has a name add. The method add. We see that the class name and the method name are identical. This one is the constructor. The class name and the method name are identical. This one is the constructor. When the class name and the method name are identical, we say it is a constructor. We can easily write a constructor when we are we use the name of the class as a method name. It is a constructor, but it has no return type. Void, int, double, float, any return type. We should not add any return type, just like void, add, int, float. And it used to initialize the class variable. It initialize the class variable a equal to and b equal to 11. The purpose of the constructor is used to initialize the class variable a equal to 2 and b equal to 7. We normally say the class a constructor when a class name and the method name are identical. The class name and method name are identical and has no return type is used to initialize the class variable. Class variable has two class variables a and b. We initialize with the value a equal to and b equal to 7. Normally, we call a method explicitly, uh, but when the constructor are called. But when the constructor are called, the constructor are called when we create a class object. The constructor are called when we create the class object. In this example, class add, we just create the class object. Create the class object. When we create the class object, it is automatically called the constructor. It automatically called the implicitly called the constructor. Is initialize the object variable object dot a equal to and object dot b equal to 7. Is initialize the object variables object dot a equal to and object dot b equal to 7. This type of constructor is a default constructor. We have no parameters and we initialize it default value. I initialize it default value. This type of constructor is a default constructor.
The type 1 is a default constructor. The default constructor has no argument to pass. It initializes the class variable with the default value. The default constructor has no argument to pass. It initializes the class variable with default value. In this example, class add, we have two class variable a and b with one default constructor add. In this constructor, we have no parameters and no argument to pass. We initialize the class variable a and b with the default value a equal to 7 and b equal to 10. Whenever we create object for this class without having any parameters, the default constructor will be called automatically. It initializes the class variable with the default value. For this object, object.a equal to 7 and object.b equal to 10. Type 2 constructor is parameter constructor. The constructor has parameter to initialize the class variable. The constructor has parameter to initialize the class variable. The class add contains two class variable int a and b. It has the parameterized constructor. It has the parameter int x and int y. It initializes the class variable a and b. Whenever we create object for this class, add object, new add, we pass the value for the parameter.
we pass the value for the parameter 9 and 11. Then it initializes the value object dot a equal to 9 and object dot b equal to 11. The next type is copy constructor. The copy constructor, the constructor pass with the class object. The constructor pass with the class object. In this example, this one is the copy constructor. The constructor pass with the class object. Add copy. We create two objects in this class. The first object is a default constructor. The first object is the default constructor will be called object1. The object1 will be initialized with the class variable object1 dot a equal to 7 and object1 dot b equal to 10. And this version is the copy constructor. We pass the object1 as a parameter. We just copy the object1 value to the object2 value. The object1 will be passed as a reference in the copy constructor, or the object1 will be passed as a reference in the copy constructor. This one is a reference. This one CPY is act as a reference of object1. So a equal to object1 dot a and b equal to object1 dot b. So they both have the same value. Object1 have the object2 have the same value. Overloading method. A single class has same method with multiple versions. In a single class, a same method with multiple versions. How it possible? The method names are identical. But they differ by number of arguments. But they also differ by data types of arguments. But not they differ by return types. They differ by return type. Method names are identical. They differ by number of arguments in method, differ by data types of argument in method, but not differ by return type. Let us see with a small example. Class ESP class example. It has a method void add. In first version, it has two parameter int a and int b. In another version, void add, it has different data type, double a and int b. It has different data type, double a and int b. First and second differ by data types. And also third versions, double a and double b. The first version both are integer, second version double and int, the third version double and double. Two arguments both are double. In fourth version, it has three arguments. Int a, int b and int c. I already say the method names are identical. Void add. Four method names are identical. Differ by number of arguments, differ by data types, but not differ by return type. All methods have same return type void or okay. How it possible? We have the main class sample public static void main. We create an object ASP object example object object dot add 7,8 both are integer, so it will call the first version 7,8 and second version object dot add 10.1, 18. The first one is decimal point, the second one is integer, so it called the
second versions. So it called the second version. And third, object.add 5.5 comma 4.5. Both are decimal point. Both are decimal point. Object.add 5.5 and 4.5. Both are decimal point. So we call the third version double A comma double B. And fourth versions were object.add. They had three parameter 4 comma 23 comma 7. So it matched the third only. It matched only the third option only, int A, int B, and int C. Likewise, the versions are matched correctly when overloading the methods. In object-oriented programming, inheritance is an important one. Inheritance is nothing but one class extends the properties of another class. One class extends the properties of another class. For example, we have the parent-child relationship. The child class extends the properties of parent class. Normally, the child one has implicit have the behavior of parent class. Likewise, the child class extends some properties of parent class, can use the properties of the parent class. The child class may also contain its own property, but can also extend the properties of its parent class. Also, one class inherit or use the properties of another class. One class inherit or use the properties of another class. A new class was created from an existing one. And one new class was creating from an existing one. We can use the extends keyword. In Java, we use the extend keyword to inherit a class. In Java, we use the extends keyword to inherit a class. For example, we have class A and class B. The class B extends class A. The class B extends class A. We use the keyword extends. We use the keyword extends. The class A is called the base class. The class A is called the base class or superclass. The class B is called derived class or subclass. This class B is called derived class or subclass. Normally we call in Java superclass A and the subclass B. Now we can see with one more example. In this example, we have two classes A and B. The class A contains two variables x and y. The class B extends A. The class B extends A. The class B contains void add functions. We just add x and y. Because class B extends A, it can use the variable of A, x and y. Because the class B extends A, it can use the class A variable x and y. We just add x and y. Now we have the main class sample 6. We created object for B. We created object for B. Object dot add. We just printed the addition of x plus y. We just printed the addition of x plus y. The class A inherited by class B. The class B use class A variable x and y because we are inherited with extends keyword. If not, we cannot use x and y. The class B add the class A variable. The class B object can easily access the class A variable, because we inherited the class B inherit the class A, so that we can easily access the class A variable. The class B can easily access the class A variable because we inherit the class B inherit the class A variable.
In Java, there are three types of inheritance. They are single inheritance, multi-level inheritance, and hierarchical inheritance. They are single inheritance, multi-level inheritance, hierarchical inheritance. Single inheritance, only two classes in single inheritance. Only two classes in single inheritance. One at a subclass and another one at a superclass. Subclass inherit the properties of one superclass. Subclass inherit the properties of one superclass. For example, class super, class sub. The class sub extends the properties of sub. The class sub extends the properties of class super. The class super has a class variable a equal to 7 and class sub has class variable b equal to 9. The subclass add both these value a plus b. In single inheritance, one superclass and one subclass. The subclass extends superclass. Here we create object for the subclass that will add the both values a plus b. Here we see the output of this program, the addition of value 16. In multi-level inheritance, the subclass will be inherited by another class. The subclass will be inherited by another class. This will continue in multi-level. The subclass will be inherited by another class. That means the subclass can also act as superclass for another class. For example, A is a superclass for B, and B acts as a superclass for C, and C acts as a superclass for D. This will continue multi-level. For example, class A, class B, class A, class B, class B extends A, class B extends A, and class C extends B, class B extends C, and class D extends C. Here we see class A, class B, class C, class D. Class B extends A, class C extends B, and class D extends C. Here we create object for D. We create object for D. Object dot add. In this we add all the variable A plus B plus C plus D. C, since class B extends by A and class C extends by B and class D extends by D. So class D can access all of these class variable. Can access all of this class variable. Class D extends only C, but C extends B. So C implicitly can use the variable of B, and B extends A. So it also uses the variable of A, class A variable. So the class D can access all the class A, B, and C variable. So we add this variable. The output of this program, the addition value is 43. Hierarchical inheritance. Simple. A single class will be inherited by multiple class. A single class will be inherited by multiple class. For example, class A can be extended by B, C, and D also. Class A can be extended by B, C, and D also. Class A is a superclass for B, C, and D. Here we see the example for hierarchical inheritance. The class A is a superclass for B, it's a superclass for C, it's a superclass for D also. The class B extends A, so it can use a variable of class A also.
So addition value of class B equal to A plus B. We can use its own variable and class A variable also. So A plus B and class C S tends A, C equal 10, it add A plus C. It can use class A variable and it also its own variables. And class D S tends A, we can use the class A variable also, A equals 7 and its own variable. So we can add A plus D. So we create object for A, object A, we create object for B, we create object for C, we create object for D. We already learned about how to create object in previous video. So we call all the class B add through object, class C add through its object, class D add through its object. Now see the output of this program. The addition value of B equal to 16, addition value of C equal to 17, and addition value of D equal to 14. B can implicitly use class A variable, C can implicitly use the A variable, and D can implicitly use the A variable. Overriding methods. In overriding method, superclass and subclass have same method. The subclass method overrides the superclass method. The subclass method overrides the superclass method. The method arguments and the return type are all identical. There is no difference in the methods in superclass and subclass. Everything are same. The method name, the number of arguments, the types of arguments, and the return types, everything are same. There is no difference in superclass method and subclass method. By overriding, Java implements runtime polymorphism. Let us see with one example. Here, the class super have method display a single string argument x, and a class sub extends the superclass sub. Also the same method display string arguments, and the printed the subclass method the string value. Here we create object for the subclass. Here we create object for the subclass. Object dot display. It just display the subclass method only. It won't display the superclass method. It just display the statement subclass method only. Subclass method, subclass only. It just override the superclass method. The subclass method hide the superclass method. The subclass hide the superclass method. In other words, we can say the subclass method overrides the superclass method. It gives some meaning to the superclass method. There is no difference in the methods. Superclass method and subclass method have same method name, number of arguments, and types of argument. Using dynamic method overriding, which we can refer the correct versions of the methods in the superclass method and subclass method also. Using dynamic method overriding or runtime polymorphism, we can refer the correct methods in the superclass and subclass method also. Here we have example class super, another class sub1 extend the superclass method, another class sub2 extend the sub1 class. All these class the same method void display. All these three classes have same method. The subclass overrides the superclass method. The subclass overrides the superclass method void display. To call the correct versions of the method, just use the reference object. We create superclass reference object. Superclass reference object. The superclass reference object refer the subclass object. The object 1 is the object for subclass 1. Super dot display, just call the subclass method 1. Subclass method 1. Whenever we refer superclass method, refer object 2, that's the object for subclass method, we just call the subclass 2 method. Subclass 2 method. To call the superclass method, we should refer the superclass object itself. Super.refer display will call the superclass method. Here we have the output of this program. Just display the superclass method, subclass method 1 and subclass method 2. Recursive function, a function that call itself repeatedly. A function that call itself repeatedly. For example, in a sequence of time, each time using its preceding time. For a sequence of sum, a sequence of time, each time using its preceding time. For example, x plus 1, x plus 2, etc. The best example for recursive function is spanning factorial of a given number. Recursive used to create cleaner and simpler version of several algorithm. Used to create cleaner and simpler version of several algorithm. For example, in artificial related algorithm, artificial intelligence related algorithm are mostly implemented using recursive function. Let us look the example for recursion, the factorial program class factorial, then create the recursive function in fact int n, only one parameter to find the factorial of a number, int result. The result will return the factorial value. If n equal to 1, return 1. Mostly the recursive function contains this if condition so that the repetition will be stopped. If n equal to 1, return n, otherwise result equal to fact of n minus 1 star n, return result. At last we return the result to the calling class, main class sample recursion public static void main string argues then create the object for the class factorial to call the function fact. Class name is small letter, so we convert to small letter. New operator. Already learned about how to create object for the class. Please refer the video given in the description. Then system.out.println the factorial of 7 is plus f dot fact of 7. This will return the factorial of the value 7. We save this file as sample recursion, because the main class in this class only sample recursion. Just copy the class name and save. .java. Then now I explain this program. Inside we create a function. In fact, inside the function call itself. The function call itself. We just create a main class sample recursion. We create object for the class factorial. Just create object for the class factorial. Using the object, we just call the function fact for finding the factorial of number 7. Just call with the value 7. Object dot fact 7. If n equal to n, if n equal to 1, it return 1. Now the value of n is 7. So result equal to fact of n minus 1 star n. Result equal to fact of n minus 1 star n. The fact function will call itself with the new value n minus 1. The fact function call itself with the new value n minus 1. Initially call with the value 7. Now it call with the new value n minus 1. That is 6. That is 6. Fact of 6 star n. Fact of 6 star n. Then the fact function call repeatedly. The fact function call repeatedly. If n equal to 1, return n. Now the value of n is 6. So fact of n minus 1 star n. Fact of n minus 1 star n. That is fact of 5 star 6 star 7. Likewise, the fact function call repeatedly. The fact function call repeatedly at the last step. Fact of 1 star 2 star 3 star 4 star 5 star 6. The fact 1 will return the value 1. The fact 1, if n equal to 1, return n. So the value is equal to 1 into 2 into 3 into 4 into 5 into 6 into last 7. Last value is 7. So the factorial of 7 is 5040. The result is obtained. Can try in your system. Fact 7. Now we compile this program and run this program. The factorial of given number 7 is 5040. Using super keyword, the subclass can access the immediate superclass member. Using super keyword, the subclass can access the immediate superclass member. The subclass can access immediate superclass constructor. The subclass can access the immediate superclass constructor. Also, the subclass can access the immediate superclass variable. The subclass can access immediate superclass method. The class members, which means both data and methods. The subclass can access the class members of the superclass through the super keyword. The subclass can access the superclass members, that is both data and methods constructor can access through super keyword. Here we see with one example calling superclass constructor. Here one class super, the class was extended by a subclass. A subclass sub extends the superclass. The superclass contains a class variable A and a constructor. This constructor initializes the class variable. In the subclass, it also has a constructor sub has two argument int x and int y. Using super keyword super x, it initializes the superclass constructor. It initializes the superclass variable through constructor. The super x called the superclass constructor. The super x called the superclass constructor. We pass the variable of x to the superclass constructor. It initializes the superclass variable a equal to p. Also, the subclass variable was initialized by b equal to y. In the main class, we just create the subclass object only. We just create the subclass object only. Sub object is initialized with two variables 11 and 21. The 11 is assigned to superclass variable and 21 is assigned to subclass variable b equal to y. Here see the output of this program. Value of a equal to 11 and value of b equal to 21. Here we see with another example, access superclass data and methods. Here with one class super, another class sub1 extend super. Here superclass has contained class variable int a and subclass contain class variable b equal to 10. Both superclass and subclass contain the same methods void display and void display. Using super keyword super.a, it accesses the superclass variable. Super.a is initialize the superclass variable. Super.a. The subclass can easily initialize the superclass variable. Super.a, it initializes the superclass variable, and super.display, it called the superclass method. Super.display just call the superclass method. Here we create object for subclass sub1 object1 dot new sub1 object1 dot display. We just call only the subclass method display. Subclass method display. The subclass method display we call the superclass method display using the super keyword. The subclass method display we call the superclass method using super keyword. Using the super keyword, we also initialize the superclass variable. Using super keyword, we initialize the superclass variable. Here we see the output of the previous program, value of a equal to 11 and value of b equal to 10. The final keyword we use to create the constant value. The first usage of final keyword is used to create the constant value. If you initialize any variable along with the final keyword, that variable value cannot be changed. Here we use final int a equal to 10. We can use any data types. Along with the data type, if you use final keyword, that value cannot be changed. If we try to change the variable value, it will be show errors. It will show the error in the compile time. Next, to prevent class to be inherited, the final keyword is used. To prevent a class to be inherited, final keyword can also be used. If you declare a class along with the final keyword, that class cannot be inherited by another class. It can't add as a superclass for another class. It can't be added as superclass for another class if you declare a class with final keyword. Here one example, final class A. If you try to extend class A, it will show error during compile time. In this, we declare class A as final. We declare class A as final. For another class, try to extend A, but it will show error during compile time. The another one is the final keyword is used to prevent a superclass method to override. The final keyword prevent superclass method to override. If you declare a method in superclass as declared, that method cannot overridden in subclass. For example, class A contains a method void display that is declared as final. If another class B extends A, try to create the same method void display will show error during compile time because we have already declared that method as final in superclass. The superclass method cannot override by subclass if we declared as final. Before studying about interfaces, you should know about abstract method. Abstract method, if a class contains a class sample, we create a method short. We just declare the method without giving any implementations, just like without giving implementation for shorting. We just declare the method without giving the any implementation for the short. It's called abstract method. We just declare this method as abstract. We just declare this method as abstract. This method is called abstract. Interface is similar to class. Interface is similar to class. It contains only static constant data. Contains only static constant data. Contains only abstract method. Contains only abstract method. Just like creating class, we create interface and interface name. Instead of using class name, here we use interface keyword. Interface keyword, small letter interface name and abstract method. Void short any method. Just declare the method. Normally, a class can be extended by another class. Likewise, interface can be implemented in another class. Interface can be implemented in another class using implements keyword. Using implements keyword, here we create interface. Here we create interface print I. Another class short impl implements that interface. Implements that interface. Just use the implements keyword. To extend class, we use the keyword extends. Likewise, here interface we use the implements keyword. The class that implements the interface should give implementations or definition for the abstract method. Here the abstract method is print. The short impl should give definition for the abstract method. Void printf, we should give any code, otherwise it will show error during compile time. Interface can be implemented by any number of classes. Interface can be implemented by any number of classes. Usage of interfaces. By using interface, we can fully abstract a class, just a class, but we fully abstract a class. A class can implement any number of interface. We achieve multiple inheritance through interface. Multiple inheritance can be achieved through this interface. A class can be implement any number of interfaces. By using interface, we achieve polymorphism. One interface, multiple method. One interface, multiple formats of method. Same method in multiple format. For example, void short. In one class will short the integer, and another class will short the string format, and another class will short the double format. Likewise, it varies. You see with the one example, interface short print ln have one abstract method void print if. We just declare that method. Another class sample if. Just give the name implement inf implements the interface. But just give the definition for the abstract method in the implementation class. Just print any we can give any definition. System dot here we print only the print message. System dot out dot print ln next we create a main class. Just public static void main. Public static void main string argues. Just create the object of the previous class. Just create object of the previous class sample lineup. Class name, object name equal to new operator class name. Using object, we just call the method print if. Just call the method print if. We already learned about how to compile and run Java. Just refer that video. Here we compile the previous program. We type Java C class name. Class name is empinf.java. Just compile, show error, void printf. Here show error, void printf. Attempting to assign weaker access privilege. Normally, the interface method should be declared as public. Public void print inf. The class that implements should also prefer as public void println. After changing, show no error. Now we compile. Then we have to run Java ESP inf. Waiting for the result. Welcome to Java interface. We just create interface name. We should use the public keyword public void printf. The class that implements the interface should give definitions for the abstract method. Otherwise, it show error. That class should also use the public. Just create the object of the class Just create the object of the class that implements the interface and calling the abstract method. Show the output. Thank you. Packages. The related classes are grouped as packages. The related packages are grouped as packages. For example, IO, input-output classes, utility classes, applet classes are grouped as packages. So packages is nothing but it's container of classes, interface, and other packages also. Packages is a container of classes. It contains classes, interfaces, and other packages. There are several built-in packages, and user can also create their own packages. Java has inbuilt several packages. For example, IO packages, utility packages, AWT packages, event packages, etc. User can also create their own packages also. Creating packages. The packages can be created using the keyword package. The packages can be created using the keyword package. The package command should be the first statement in Java source file. Package command should be the first statement in the Java source file. Any class that created within that file that belong to the specified packages. Any class that is declared within that file, that class belong to the specified packages. Here the package keyword and package name. Package keyword, the package name. We can also create multi-level packages. That means package contains another packages. Package contain another packages also. For example, Java AWT packages. In that packages contain another package event. Importing packages. The classes that is created inside the packages can be used in another classes or another Java source file. The class that declared inside the package can be used in another package. Java uses the import statement to bring certain classes or entire classes into visibility in another Java source file. Java uses the import statement to bring certain classes or entire classes into visibility in another Java source file. For example, import java.io.star. Import java.io.star. After the package statement, you can use the import statement. Import any Java class packages. Now we can see with one example the package keyword and package name. Any package name, packaging sample. Then after that, create any number of classes. Here, for example, we create only one classes. Sample underscore packaging. This package contain only one method, print packaging. We just print the welcome command, system.out.println welcome package. Welcome package. Just close the class file. Before saving the Java source file of package, you should create a folder with naming the package name. I create the package name pkg sample. The folder name and the package name should be the same. Now we can save this file. Save as video class. In that we create a package sample folder. In that folder, you say this class name sample pkg, sample underscore pkg dot java. The package pkg sample in can be imported in another Java source file. Import package name dot star. Dot star means you can import all the classes in the pkg sample. Then we create a class, main class pkg m public static void main string argues. Then we have to decide which class we have to access. For that class, we have to create object. We have to decide the package can contain any number of classes. In this class, we contain only one classes sample pkg. In the class, contain only one method print pkg. So that we should create object for the class sample pkg. We should create object for the class sample pkg, sample underscore pkg, object name equal to new sample pkg, object dot. Here we should access the method print pkg, print pkg. For the sake of example, I just create the class name and package name for the sake of example only. Then we should save this class pkg main in the we create the package folder pkg sample. Just outside the folder we should save this file java pkgm.java. This package folder just outside we should save. Just outside we should save this java source file. We should save this. Before using the package classes, we should compile that package classes. I just move to the package folder pkg sample, and also I set the path. Set path equal to the path location of the Java bin. I compile. We show error package pkg sample have no semicolon. I just change and save and recompile. It doesn't show any error. Now we can import this package in any Java source file. The class which we declared inside the package should give the access privilege. We change the access privilege of this classes into public, and the method also we declared as public method, so that we can be used these classes and method in outside of this package. We already compiled the package file. After that we should compile the Java source that imports this package. We have to set the path for this folder. Then we have to compile javac pkg name dot Java pkgm dot java. Yes, run this Java source file. Welcome package. The package sample contain the class sample pkg, contain the functions print pkg, just print the welcome package. That package is imported in another Java source file. Create the object for that class to access the method, and we call the method to print the message. You can easily create package and also import the package. I think we have learned simple usage of packages and how to import the package through this video. Hello. Today we are learn about exception handling in Java. Exception in Java is a mechanism to handle runtime error. Before the coding was deployed, all exceptions are predicted and handle that error without giving burden to novice. Also used to run Java source program error-free. There are two basic blocks in exception handling. They are try and catch. The Java source code that want to monitor or exceptions are put inside the try block. The try block contains the block of code. The try block contains the block of code. It monitors the error. It monitors whether any errors occurs in the try block. The try block will monitor any error that may occur in the try block. If any error occurs, the try block will throw that error. If any error occurs inside the try block, the error will be thrown out. Immediate after the try block is catch block. Immediate after the try block is catch block. The catch block will handle the error. It just handle the error that was thrown by the try block. The try block will monitor whether any error occurs. If any error occurs, it just thrown to the catch block. The catch block will handle the error. In Java, all errors are categorized and grouped as classes. The superclass is throwable. The immediate subclass is exception and error. The exception error is runtime error. The error is hardware error. The exception contains several subclasses. There are IO exception, SQL exception, class not found exception, and runtime exception. The runtime exception contains several subclasses: arithmetic exception, null pointer exception, number format exception, index out of bound exception. The index out of bound contains array index out of bound exceptions. All errors are categorized as classes. Every errors we give name in Java. Here one example. There are three variables A, B, C, and variable A is initialized with 0 and B equal to 11. We try to divide B by A. B equal to 11 and A equal to 0. Anything is divided by 0 is infinity. Anything divided by 0 is infinity. It is an error. So that we write in try block. Anything is divided by 0 is an error. So that error was thrown inside the catch block. Divide by 0 is under the category of exception, arithmetic exception. So it is thrown and catch inside the catch block, and that error was printed. Now we compile this program, Java C program name.java. And now we run this program, Java sample ESP. We show the error and print the reason for error, java.lang.arithmetic exception. This message is printed through the object of the catch statement. See this error. We just only print the error message, and plus E. We print the what type of error. Java.lang.arithmetic exception. The reason for error divided by 0 is just print through the arithmetic exception object plus E. Just print the what type of error and the reason for error. Okay, thank you. We will meet in another video. Exception is a mechanism to handle runtime error. The try block can have one or more catch block, and each catch block can handle the matched exception. Each catch block can handle one exception only. The try block can have any number of catch block. The match catch block will be executed. If the try block throw type 1 exception, this catch block will be handle that exception. If the try statement throw type 2 exception, this type 2 catch block will handle that exception. If the try block throw type 3 exception, this type 3 catch block will handle that exception. Here let us see with one example, a try statement and two catch statement. The try statement, we throw an exception, divide by 0 error, arithmetic exception. We already learned about this. And we throw an exception, array index out of bound exception. We allocate an array of size 5. We allocate an array of size 5, but we try to initialize a of 100 equal to 10. The array size only 5, but we try to initialize a of 100 equal to 10. It is an exception, array index out of bound exception. Now we compile this program and run this program. We throw an exception java.arithmetic exception. Here the first exception is divide by 0 exception. So that exception is thrown and catch first. Whenever an exception is thrown, the below statement will not be executed. The statement will not be executed. The control is just passed to the catch statement. Just place this exception in the first place. If this exception is in the first place, now we compare this program. Before that we have saved. Now we compare this program and run this program. Now the exception is array index out of bound exception. The first exception is thrown, array index out of bound exception. The control is just transferred to the catch statement. The below statement will not be executed. Welcome to Easy Tech Coding. In this video, we learn about throw keyword in exception handling. We already learned about exception handling in Java and also multiple catch statement. Please refer the video description. Now the throw keyword. The throw keyword is used to throw an exception explicitly. Normally in Java source code, the exception is thrown implicitly, but using throw keyword, we can throw an exception explicitly. We can throw either check exception or uncheck exception. In certain condition, we may throw an exception explicitly. In certain condition, we may throw an exception explicitly. The syntax is a new operator, the throw keyword, any exception, and name of the exception. For example, the new operator, the throw keyword, arithmetic exception, the reason is divide by 0. We can throw only instance of throwable or subclass of throwable class. Let us see with one example. Here we throw arithmetic exception for the sake of example only. Using throw keyword, new operator, thus arithmetic exception is thrown. The name of the exception. If the value of e equal to 0, we throw an exception explicitly. The value of e equal to 0, we throw an exception explicitly. E is assigned with the command line argument, array of 0. Let us compare this program and run this program. Java program name 0. This 0 is assigned to the command line arguments. This 0 is assigned to the command line argument. Whenever we run this program, the exception is thrown. Exception thrown by EC code. Exception is thrown by EC code. Whenever the value equal to 0, the exception is thrown explicitly. Coding. Today we have learned about exception handling using throws keyword. The throws keyword is used along with methods if the method does not handle the exception. Suppose the method throw an exception. If it does not handle the exception, the throws clause can be used along with methods. The caller of the method can handle the exception. The caller of the method can handle that exception. The throw clause can list the type of exception it may throw. The throw clause can list the type of exception it may throw. Throw exception explicitly. It can throw either check exception or uncheck exception. The syntax is the data type, the method name, the parameters list. Here we use the throws exception. If this block throw the exception, that exception list may be listed in the along with the throws clause. The exception list can be listed along with the throws clause. The exception list is a list of exceptions that the method can throw. Let us see with one example. Here we create a class sample7 having one method, method1. We throw an exception explicitly. We already learned about how to throw an exception explicitly. We refer the description of this video. In this program, we throw an exception explicitly, but this method having no try statement and catch statement. It does not handle the exception. The method does not handle the exception, so that we use the throws class. It just lists the type of exception it throw. The method does not handle the exception. It does not having any try or catch statement. So we include the exception list using throws class. The caller of the method, here we create object for the class sample and call the method. The caller of the method handle the exception. The caller of the method handle the exception. Now just compile and run this program. It print the output hello and the type of exception and the message. The type of exception and the message. The message is printed through the object we passed. The message is printed through the object is passed. The finally keyword in exception handling is a default block for try statement. It must be executed whether the exception thrown or not. It is optional. It always executed after the try block. We already learned about exception handling, try block, catch block, and throws keyword. Now finally keyword. It is a default block for try statement. It is an optional statement. It's always executed. Let us see with one example. We create a program class sample finally, and then write public static void main, public static void main string or yours command line argument, then try block. In try block, just print a statement. Easy code. Just print the welcome message. Easy to code tech and catch block. We have tried catch block arithmetic exception. And now just print the statement. System dot out dot println. System dot out dot println. Just print the message if it's through. And just finally block println. Just print the statement default block. Default block. Then close the program, save it. Just run this program, compile this program. The output of this program is default block. It's a code default block. Now we throw an exception explicitly. Throw new arithmetic exception. This exception is caught in the catch statement. Also, the final block is executed. Save this program and recompile. Run this program. The exception is caught and final block is executed default. Package for handling event. Java contains the package java.aw.event.star package. It handles all type of event. When there is change in state of object is called event. Event can be foreground event or background event. Foreground event occurs when user interact with graphical user interface component, for example button, checkbox, text box, keyboard and also mouse. Background occurs when time triggers or hardware failure, when there is an interrupt or operation completion. Normally, background event occurs automatically in the background state. Time elapse, hardware failure, or any interrupt occurs. Java, it supports delegation event model in that source generate the event and one or more listener can handle that event. Listener is an interface. To handle the event, the source must be registered with the listener. For example, for key event, it must be registered with add key listener. Event class and event listener. Every source must be registered with event listener. Then only the event will handled by the listener method. There are many type of event. Let us see one by one. Event, action listener. This event occurs when button pressed or selecting clickable menu item. Then adjustment event, adjustment listener. This event occurs by adjusting the object like scroll bar or scroll pane. Then component event, component listener. It occurs when using AWT component. It moved, size or change its visibility. Then container event, container listener. It occurs when we add component or removed. Then focus event, focus listener occurs when component receive focus. that is focus in or focus out. Then item event and item listener, it occurs when item selected or deselected. For example, choice box, it is selected, or radio button selected or deselected. Key event and key listener, it occurs when we are using keyboard, that is when we key pressed, key released, key type, etc. Then mouse event, it has listener, mouse motion listener, occurs when we use mouse, like mouse pressed, mouse click, mouse entered, mouse assisted, mouse track, etc. Mouse wheel event and mouse wheel event listener. This event occurs when rotating the mouse wheel. Test event or test listener occurs when character enter in text box and test area. Window event, window listener occur when change in window state, that is window open, close, activated, deactivated, etc. Applet basics. Applet is a Java graphical user interface program that can be embedded in the web page. It can be run on web browser on client side. Applet can be embedded to HTML page using Applet HTML tag. Applet can be used to create dynamic website. It is secure. Also, it is less response time. Since Java is platform independent programming, Applet can also run on multiple platforms. That means Windows, Linux, macOS, etc. The package for using Applet in Java source code is import java.applet.star. Before writing Applet program, we should import this package import java.applet.star. Then life cycle of Applet or skeletons of Applet. These are the important methods of Applet: initialization, starting, painting method, stopping, and destroying the applet. Applet initialization. When applet load, init method executed first. All initialization steps are in this method. The skeleton is public void init initialization code here. Start method, it is called after init method. Start method is called each time an applet is displayed on the screen. For example, if a user leaves a web page and come back, the applet resume execution by start method. The skeleton is public void init the action for the applet. The paint method is an important method. It displays the applet component on screen. The paint method is called each time the applet output display. It is called an applet window is displayed after it minimized, restored, or covered by another window. Whenever applet must redraw its output, the paint method is called. The paint method has parameter graphics. It has only one parameter, that is graphics, maintaining the graphics component in which the applet was running. For example, pixel of the screen, it maintains. The skeleton is public void paint, the graphics component parameter, and the code to display or redisplay the content of screen. The stop method, it is called an applet output stop. That is, the browser leaves the HTML document containing the applet. Also, when suspending executions, that means the applet window covered by another window. The skeleton is public void stop suspend execution. The last one is destroy method. It is used to remove the applet completely from memory. It's just like destructor, doing job like free up resources that may be used by applet. The skeleton is public void destroy, resource free up, shut down activities. Let us see with one example, applet program. The applet program should import this package, import java.applet.star. The class should extend the applet class. This one is the applet tag. We should write the applet tag. Then only the applet window will be open. Applet code equal to the name of the class name. The name of the class name and this code should be equal and it is case sensitive. Then width and height of the applet window. Just we display the welcome message, welcome to Applet in public void paint method g dot drawstring. In console we write system.out.println. In applet we write g dot drawstring and the welcome message welcome to applet. This one is the xy axis to print the message in applet window. This one is the x axis and this one is the y axis. Then we compile this program java c the class name dot java and run this program applet viewer. To run this program we run as applet viewer class name dot java. The applet window will be open. The applet window, this one is the applet window and welcome screen, welcome to applet. In this video, we learn about how to create button and label in Applet with simple program. Now we are creating a sample Applet program containing app button and label. Import java.applet.star for creating applet.star for creating the applet program. Then import java.awt.star, import java.awt.event.star for manipulating the event that is generated by the button. Then create public class name sample button extends applet implement action listener. We already learned about applet class and listener. The listener should be implemented to handle the event. For a button, the action listener should be implements. Then create a button. Java is an object-oriented language. Everything is based on class. To create a button, just create an object for a button. To create a label, just create an object for the label. So for creating button, just create object for button. Button click equal to new. Just like creating object, we just creating button. Button is a class name. Button name click. Give the name of the button click. Then create label L test equal to new label. Just give the name of the label click button. Then create another label equal to new label. Produce the output of the button. So now we empty this label. Now public void init we should add the button and label in the applet. For this we use this add function. Add click. Then only the button will be added in the applet window. Then add test. This function add the label in the applet window. Add text one. Add label and button in the applet window. If you hide this, it will not add in the applet window. Then to perform the action, we should add action listener for button. For this, click add action listener. This we should register the button with the action listener. We should register the button with the action listener so that the output will be produced. Otherwise, there is no reaction. If you produce a reaction, the button should register with the listener. Then for action listener, the function is public void action performed action event. The parameter is action event. We note that if you note every class starting with letter capital, every class starting with letter capital. For example, class Applet have capital letter A, class button have capital letter B, class button has capital letter L, and every function starting with the small letter and every function starting with the small letter, action perform starting with small letter. Then the action is test one dot set test. We set the test as the button is click. Also set the show the status bar. Status button is click. Button is click. Now we close everything. Public class sample, extends applet, implement action listener, register with the button, then action performed. We should add everything we create the ability component in the applet window through this add function. Then applet tag, the applet tag. The applet tag, the code of the applet tag is the name of the class, and width and height is to be set. Save this file as samplebutton.java. The class name, only one class name. So save this file name as samplebutton.java. Now compare this program JavaC button samplebutton.java. Then run this program. Applet viewer sample button. Applet viewer sample button. To run the applet program, we should use this command applet viewer sample button.java. The applet window is open. Applet window is open. Button and label. Button and label. We create the button. The name is click and label click button. Click button and label. If you click this button, you show the status button is click. The button is clicked. Also, another label is created. The button is clicked. Very simple. The Applet program is very simple to create. Just import this package extends Applet for button implement action listener. For button implement action listener, several components have different action listener, different listener. For example, choice bars have item listener. For action listener, the function is action performed. Okay, you will try this program in your system. Hi, welcome. In this video, we learn about layout manager and their types. Layout manager used to arrange AWT component in particular order. Used to arrange AWT component. It may be label, button, checkbox, test area, any AWT component. It adjusts the size of component. It position and adjusts the size of component. Also, it adjusts space between two component, AWT component. It adjusts the space between any two AWT component. That is horizontal space and vertical space. Any two component, for example, any two component, this one component and this component. It adjusts the space between this component, these two components, horizontal space and vertical space, horizontal space and vertical space. Layout manager is set by set layout method. Void set layout manager object. Layout manager is made the object of any layout manager type. Types of layout managers: flow layout, border layout, grid layout, chord layout, grid back layout. In this video, we learn only border layout. In subsequent video, we learn other layout also. Border layout arrange components in 5 regions: east, west, north, south and center. This constructor is border layout and border layout, horizontal space, vertical space. The 5 regions of constant integer: border layout center, border layout east, border layout west, border layout north, border layout south. When adding component in Applet window to set region, use this function void add component, any component. It may be button, label, etc. along with the region, object region. Region is border layout dot center or east, west, north, south, etc. Let us see with one small example for the border layout. Import java.awt.star, import java.applet.star. For using applet, you should import this package java.applet. For using AWT component, you should import this package java.awt.star, the package AWT package. For using button labels, etc. Here we are using 4 buttons L1, L2, L3 and L4 and one label L5. In public static void main, we set layout new border layout. We set the border layout using the set layout method. Set layout new border layout, and we initialize the button L1 equal to new button. This will be displayed in north, and L2 we initialize the L2 button in south. This will display in south. Also we initialize L3 button east, and also we initialize L4 button west. And we set the label in center. This will display in center. We set layout for this AWT component for button, we set add L1 border layout dot not. We are we usually add AWT component in applet using the function add. Along with we set the region. Along with we set the region add L1 and border layout dot north and add L2 border layout dot south, add L3 border layout dot east, and add L4 border layout dot west. These are the buttons. We set the region for these 4 buttons using the add function. This add function is one of the function to add AirType component in the applet window. Along with we set the region. Along with the add method, we set the region. Set the region border layout dot north, border layout dot south, border layout dot east, and border layout dot west. We set the region for the label. We set the region for the label L5 border layout dot center. Border layout dot center. We set the region initialize the AWT component in public void init method. In this public void init method, we do all this job. Initialize buttons and label, set layout, and adding the AWT component in the public void init method. And also in applet code equal to a sample border. The name of the class name and the code should be the same, and also set the width and height of the applet window. Now we compile this program Java C sample border Java. We should set the path equal to C colon / program file Java / JDK / bin. Now we compare this program. And run this program applet viewer sample border.java. The applet window is open. The applet window is open. The applet window is open with the 4 region. In north, in west, east, and south. In the center of the applet, we set the label. This will display in center. The label is displayed in center. The label L5 is displayed in center. And the 4 buttons, east, west, north, and south, set in the layout border layout dot north, border layout dot south, border layout dot east, and west. The applet output is shown here. Try this in your system. Hello, in this video we learn about flow layout in applet. We already learned about layout manager and their types. Refer the video description. Flow layout is a default layout similar to Wordflow in test editor. You can type the word from left to right or right to left, etc. The default constructor for flow layout is flow layout with center alignment, and horizontal and vertical space between AWT component space is 5 pixel. Default is 5 pixel. The another constructor flow layout init alignment and horizontal space and vertical space. We can assign the pixel of horizontal space and vertical space between the AWT component. Now the alignment property for flow layout. First one is left, align component to the left. Then right, it align component to the right. And center, it align component to the center. Leading, it will be at the leading edge of container to the left for the left to right orientations, and trailing will be at the trailing edge of container. Now let us see with one small example for flow layout. The applet import java.aw.star for using the AWT component buttons. We should import this package, import java.aw.star. For applet, we should import this package, import java.applet.star. Then the class name public class. The applet class name should be public. Public class name extends applet. We create the button for the sake of example only. Button L1, L2 for 10, 11 button we use. Then public void init. The public void init method only we set the layout. We set the layout in void init method. Normally we set the layout for the applet in the public void init method using the set layout method. Set layout method, and we initiate the flow layout. New flow layout and the alignment flow layout dot left, and the alignment flow layout dot left, and we create the list of button. We create the list of button from first to 11 button, and we add the buttons in the applet window using add method, and we add the buttons using add method. If you hide this, the button 1 will not be displayed in the applet. If you want to add in the applet, you should use this add method. The add method will add this button in the applet window. Now we compile this program. Then run this program. Applet your class name sampleflow.java. The applet window is open. The orientation is flow layout dot left. So the applet window, the AWT components are display from left to right. If you try to change this orientation, for example, right, before saving this, I show this left to right. After saving this, changes as right and save this. Control S and recompile this. Before that, it close and recompile and run this program. See the difference. Now the applet display the buttons from right to left. See the difference. The applet display the button from right to left. Now I change this as default. I just change this as default. The default is center. And Control S to save and recompile this program. See the difference. All buttons are aligned in the center. Just see the difference. All buttons are aligned in the center. Set the layout using set layout method and flow layout. The default is center. If you want to set align right, flow layout dot red. If you want to center dot left, flow layout dot left. If you want to set flow layout dot leading, just change this right as leading. Trailing, just change this right as trailing. You can try this program in your system. The program will be displayed in the description of this video. Thank you. Hello, welcome. This video we learn about Java frame program to develop calculator program. This is the output of this calculator program. We create this using frame window, the test area, the test box, and the button are numbered and the arithmetic operation, division, multiplication, subtraction, plus, equal operator, etc. In this we create a three panel, and the second panel we just add the test box, and the third panel we add the buttons in grid format, and we add both the second and third panel in the first panel. We create three panel. The second panel we add the text box, and the third panel we create buttons in the grid format, that is grid layout. We add the buttons. The panel 2 and 3 we add both panel 2 and 3 in the panel 1. This is the panel 1. Both panel 2 and 3 add in the panel 1. Let us overview the calculator program. Okay, let us see the program, the source of this program. First, import java.aw.star abstract window toolkit. Before using this button and test field, we should import this package aw.star so that we can use this button and test field. For event handling, we should import this package java.aw.star so that we can handle the event of this program. Then the class name, public class calculator. We use frame in this program. So that we extend frame. For button, we use action listener. For button, we use implement action listener. We already learned about event handling. Please refer the video. So for using button event, we implement action listener, extends frame, implements action listeners. The class should be declared as public. The class should declare as public. The string s, we create a list of variable for the purpose of calculations. First we create a string s. Next the list of variable n equal to 0, value, sum, difference, multiplication, divisions. Then int op and test field, we create the test field. Create the test field for creating the test field, and list of buttons. For number 1, number 2, number 3, number 4, number 5, number 7, 8, 9, 10. We create the list of button. We create the list of buttons. And plus, subtract, multiplication, division, equal, and CZ button. Just see the output. We create the list of buttons. Then for using frame, we just create the constructor of this class. Public constructor, public calculator. Yes, public calculator. We call the constructor, create the constructor, public calculator, and then super calculator. For giving the frame name, we just give the frame name super calculator. Then we create panel 1 and 2. We create two panel. Initially we create two panel 1 and panel 2. We set the layout of the panel to us, set layout, new layout, flow layout dot center. We just create the panel to us, flow layout dot center. Panel 2, we set the panel to as set layout, new flow layout dot center. Just see the output. We just add. Wait a minute. Just see the output. The test box in the center of this window. So we add panel 2 flow layout dot center. Then we add the test field. TF equal to new test field. The number of character is 10, number of characters allowable is 10. We add the test field in the panel 2. We add the test field in the panel 2. pn2 dot add. We add the test field in the panel 2. Then we add panel 2 in the panel 1. Then we add panel 2 in the panel 1. We already discussed about, we create 3 panel. Okay, the panel 2 we create the test field, and panel 3 we create the list of button. Okay, the TF is the test field. We create the test field and add the test field in the panel 2, and panel 2 itself added in the panel 1. Panel 2 is itself added in the panel 1. Then we create panel 3. Then we create panel 3 and set the layout of the panel 3 as grid layout. 4 cross 2 matrix. 4 cross 2 matrix. Just create the output. 4 cross 2 matrix. Just create 16 buttons. Just create 16 button. 1, 2, 3, 4 and 1, 2, 3, 4. 4 cross 4 matrix. 16 buttons we create. So panel 3 equal to set layout, new grid layout 4 cross 4. The 4 cross 4 matrix format, grid format, we create the button. Just add button 1, give the name of the button 1, and button 2, button 3, button 4, button 5, 7, 8, 9 and 0, etc. 8, 9, 0, etc. Then we create the operator of the button. Then we create the operator of the button: plus, subtract, multiplications, division, equations, CC button. Then we add all these button in the panel 3. The panel 3 we set as grid layout. Panel 3 we set as grid layout. Then we add all these button in the panel 3. Panel 3 dot add all these button in the panel 3. So that panel 3 look as grid format. Then we add all these button in the panel 3. Then we add panel 3 in the panel 1. Then we add panel 3 in the panel 1. Then we add panel 3 in the panel 1. And add panel 1 in the frame window. And add panel 1 in the frame window. Add panel 1 in the frame window. Once again I said we create 3 in the panel 2, we add the test box. We add the test box. In the panel 2, we add the test box. We add the test box. And the panel 3, we form a grid format, 4 cross 2 format. Button we create. Then we add both panel 3 and panel 2 in the panel 1. The panel 1. Both panel 2 and panel 3 in the panel 1. Panel 1 we just not visible to us. Just add panel 2 and panel 3 in the panel 1. It's just a layout. We designed three panel 1, panel 2 and panel 3. Now we register all these button with the action listen interface. We register all these button 1 to 0. Then all the operator button, should register with the action listener interface, so that the button will handle the event. We already learned about action listener. Please refer that video given in the description. We add all these button with the action listener interface. Now we create window listener. Public void window closing. For closing the window, we create the window listener. This is window adapter. We have window activated, window deactivated, several window function. In this program, just want only the window closing event only. So that we create the adapter. We just create any window event. Just create window closing. For that, using only one event, we should use the adapter, Windows adapter class. This is the important part of the program, public void action perform. Public void action perform. If you press the button, this function will be called. If you press any button, this function will be called. For example, if you press the button 1, if you press the button 1, the number 1 is printed in the text box. If you press the number 2, the number 2 is pressed in the text box. Here the coding, if get source equal to b1, it gets source equal to b1. That means if you click the button b1, then add number 1 in the text box, then add number 1 in the text box. Test field, this is the object of the test field dot set test. For adding the number 1 in the test field, any number, for adding the any number or character, we just use the function set test. Set test equal to tf dot get test plus 1. Just add the number 1. Then for any button we click, the test field will be updated. For any button we click, the test field will be updated. Just see the output. For any button we click, the test field will be updated. For example, we just press the button 1, just press the button 1 and then the button 2. Button 1, then we concatenate the number 2. Okay, just add the number 1, then tf dot get test. Tf dot get test, already added number plus number 2, already added number plus 2, and also this already number added plus 3, already number added plus 3. Okay, the already added number concatenated with the another number. If you press number 5, the number 5 concatenated with 1, 2 and then 5, just using the concatenate function plus. This is the concatenate function. Tf dot get test will return the already entered number. For example, we already enter 1 to 5. This function, for example, if you want to click the number 6, the tf dot get test, we have the return the number 1 to 5. We'll return the number 1 to 5 along with if you plus add a number 6 plus 5. This is a concatenation function, plus 5 concatenation function. If you click CC, the test field will be empty. If you click CC, the test field will be empty. Here the code get source equal to CC. Get source equal to CC. Get source is this is the action event object. Will return all the source of the event. That means whether we click number 1, 2 or any operator function, if you click CC, the test field will be null. The test will be set as null. After clicking the equal button, we just compare whether we click the operator plus, minus, multiplication, etc. After clicking the equal button, we check whether we click what operator we clicked, whether it is plus operator, minus, multiplication, division, etc. Now let us check with the plus operator button. For example, if we click the number 1 and 2, if we click the number 1 and 2, then I click the plus button, the test field is empty. Okay, after clicking the test button, the test field is empty. The number n is assigned with the test field value. Number 1 is assigned with the test field value. The test field got get test. the test field dot get test. We add the number 1 and 2. That integer dot parsing will convert the test field string value into integer value. The test field is default in the string format, that is converted into integer format. Integer dot parsing will convert the string value format of test field into integer format. S equal to plus dot get label. The label of the plus button is the plus object. The label of the plus button is plus. The variable S is assigned with the plus symbol. The variable S is assigned with the plus symbol. Now we already click the plus button and enter the number 1 and 2. Then I click the number 3 and 6. Number 3 and 6. The number 3 and 6. Val equal to integer dot parseInt tf dot get test. Now enter 3 and 6. That value is assigned with the variable val. Integer dot parsing tf dot get test. The val is assigned with the value 36. Then I click the equal to button. The value is 48. Now let us see how is happen. If s dot equal plus, we already assign s with plus. Sum equal to n plus n. Sum equal to n plus the value n is already we already assigned the value for n. Then n plus value. That sum will be printed in the test field value. That sum will be printed in the test field box. Tf dot set test string dot value of sum. Likewise, the other operator it function also. Thank you. Kindly subscribe our channel. Thank you.